Hi everyone, welcome back to another Algebra 1 tutorial. In this video we'll be going over solving polynomials and binomials.
Adding polynomials. Polynomials can be combined/added, however only those with the same exponents and variable. For example, suppose we tried to add 15m to the power 3 plus 6m squared plus 2m to the power 3. We can only add the 15m to the power 3 and 2m to the power of 3 as they both have m to the power 3. But we cannot add 6m squared since this one is m to the power 3 but this one's m squared. So our final product will just be 17m cubed plus 6m squared. So similar to the way that polynomials can be added, they can be subtracted, like this problem. So we have 0.9 y to the power of 5 minus 0.4 y to the power of 5 plus 0.5 x to the power of 5. And then at the end, y to the power of 5. So they can also be subtracted. So for example, here 0.9 minus 0.4 would give us 0.5. And similarly, we have y to the power of 5 here, so it would just become, do we have 0.5 plus 1? So that just become 1.5 y to the power of 5 plus 0.5 x to the power of 5. So now let's do a few problems where we can add and subtract polynomials. So we have 7a squared minus 10a squared plus 9a. So over here we can see that only a squared is here and then 9a separate. So we can only add these two with each other. So it would become negative 3a squared plus 9a. Or 9a minus 3a squared. Now let's do this one. So 0.07 r to the power of 4 plus 0.32 r to the power of 3 plus 0.19 r to the power of 4. So over here, we have r to the power of 4, r to the power of 3, and again r to the power of 4. So we can only add these two, so it would become 0.26, since 19 plus 7 is equal to 26, r to the power of 4, plus 0.32 r to the power of 3. So this is their solution. And suppose we have another problem where they're in brackets. So we have 3.7 q squared minus 8q plus 3.7. All of that added with 4.3 q squared minus 2.9 q plus 1.6. So over here we can add this one with this one. Oh no. So we have squared in this, so we cannot add any of these since all of these cannot be added with each other. So, and similarly over here. So instead it would just become, so all of this will just become, so we have 3.7q 7q squared minus 8q plus 3.7 and then plus 4.3q squared minus 2.9q plus 1.6. So we have 2.9. So now we can add these with each other and subtract them. So 3.7q squared can be added with 4.3q squared. So it will just become 7 plus 1, which is 8. So we can just make, so it will just become, let's put a line over here. So 8q squared minus 8q, so minus 2.9, so that would become 10.9q, 10.9q plus 5.3, and that would be our solution. So 8q squared minus 10.9q plus 5.3 would be our solution. And since all of these are unlike terms, this is completely simplified. Multiplying polynomials. So whenever polynomials are multiplied, the constants are multiplied normally. For example, we have 9m times 9. It would just be 81m. Since 9 into 9, it would just be multiplied as is. On the other hand, when we multiply exponents, we basically add the powers. So we did x times x, or maybe we should do x to the power 1 times x to the power 1, which is basically x into x. So whenever we have this type of problem, you can think of it as x to the power 1 times x to the power 1, which basically means that you're adding the powers with each other to make x to the power 2, which is x squared. So whenever you're multiplying two polynomials with each other, all you're doing is adding their powers with each other. So x to the power 4 plus x to the power 4 would still give you x to the power of 8. And so on. So now let's look at binomials. So said in the last video, I showed you a chart, which I'll show on the screen right now. So this chart basically shows like the different things. So a binomial is so it's a polynomial which has two digits. So x plus 3 or x plus 2, all of those are examples of binomials. So binomials are basically polynomials with two monomials. So there's a specific way to multiply two binomials with each other. So we have x plus 3 into x plus 2. So this method is called FOIL. So F means first, O means outer, I means inner, and L means last. So what this means is, you first multiply the first two terms with each other, x squared, then you multiply the outer two terms with each other, so that's 3 into 2, which is 6, or outer terms as in the first and the last terms. So x plus x into 2, which is 2x. Then you multiply the two inner terms, which is 3 and x. And then you multiply the last two terms, which is 3 and 2. And now you can simplify to get x squared plus 5x plus 6. And that's the example of a trinomial since it has 3 digits. So now that we know that whenever you multiply two binomials, you get a trinomial, let's look at special products of binomials, or basically special trinomials. So one example is the perfect square trinomial. which is basically one polynomial or one binomial squared by itself. So we have x plus 2 from the previous example. Instead of being multiplied by x by 3, it's squared. So the output that comes by this, so x into x, so just think of it as x plus 2 into x plus 2, because that's what it is. So just, however, instead of getting the output as just x squared plus 4, you would instead get x squared plus x plus 2, x into 2, plus x into 2, which is 4x, plus 2 into 2, which is 4. So this right here is a perfect square trinomial, since it's x plus 2 multiplied by itself. Another one is a difference of two squares, which is not actually a trinomial, but instead it's a binomial. So what you call these are special products of binomials. So we have a plus b into a minus b, which after you do all the math, you realize that the inner terms and the outer terms multiplied with each other counter each other out, so they cancel each other out. So we just get a squared minus b squared. And this is known as the difference of two squares. So here we have a picture showing what special products of binomials are. So perfect square trinomials and difference of two squares. So now let's do a few problems. So we have x plus 7 squared, which is basically x plus 7, which is basically x squared plus 14x plus 49. And a way to think of it is the first term is x multiplied by itself, or the beginning term multiplied by itself. You can think of the second one as the last term of, so what I'm trying to say is x plus 7 squared. It's basically this squared first, then this into this times 2, and then this squared, which is basically what it is, this squared, then 7x into 2, which is 14x, and then 49, which is 7 squared. And then let's look at this one, 7a minus 2b squared. So this will just give us 49a squared minus 4b squared. Finally, let's do this one, 9 minus x cubed into 9 plus x cubed, which is 81 minus x to the power of 6, because it's x to the power 3 into x to the power 3, which is x to the power 6. This would actually be our final answer. And suppose we're told to do the opposite, which is solve for the binomial of a trinomial. So suppose we have x squared plus 8a plus 16. So the way we would solve this one is, so first you need to look at what numbers can make up this, and also when multiplied by each other make this, or not 8a, sorry. So x squared plus 8x plus 16. That's what I meant. So here we can see that x has to be the first term, and then what times 2 gives 8x? Well, it's 4. So just be x plus 4 squared, because 4 into 4 is 16, 4x into 2 is 8x, and x squared is x squared. And similarly, we suppose we have 64 minus x to the power 4, this would just be, it's a perfect square. Or not a perfect square, it's a difference of two squares. So what this is 8 plus x squared to 8 minus x squared. Because that's basically what it is. X squared to x squared just gives x to the power 4, and 8 into 8 just gives 64. So this is the binomials which are multiplied with each other. So yeah, that's all I have for this video. I hope this video helped you with solving binomials and polynomials. And yeah, thanks for watching, and I hope I see you next time. Bye.